What's the electronegativity of nitrogen? Well, we can look up that on the table. Do you recall? 3.4? That sounds about right. 3.4. But let's just confirm that. It's a little bit maybe on the higher side, but very, very close. It also depends on what chart you look at. You know, the reason I know it because I have the numbers for Chem 1A because I've seen them so many times. In the Chem 1A book, it's very easy to memorize. It's 4, 3.5, 3.0, so it just goes half down. And then also chlorine is 3.5 too. These numbers, what you're going to see is you're going to see a little bit of variation because of how they're calculated and which ones people are using, the Paulings or whatever else. There are a number of different electronegativity charts out there. Hydrogen is what? Hydrogen in this book is a 2.2. Hydrogen in the Chem 1A book is a 2.1. It's off a little bit, but the difference is 0.4 for carbon hydrogen. What's the difference between nitrogen and hydrogen? 2.2, 3.0, it's going to be a delta En of 0.8. See that? 2.2, 3.0, delta En of 0.8, which means it's slightly polar. We call it a polar covalent bond. And so the reality is it's more covalent than it is ionic. It's somewhere in between. Okay, now with the particle, what do we do about the ammonium? So ammonium is a bit more tricky because there is that thing here. But the way we do ammonium is like this. When I look at the polarization of the electron cloud here in ammonium, I look at the formal charge. There's a formal charge planted on that nitrogen. And that gives us a positive net charge here. When I look at this positive charge, what that's going to do is it going to make nitrogen more electronegative or less electronegative if it has a positive charge? Is it going to want to pull in more of the electron cloud or pull in less of the electron cloud? Electron cloud's negative. It's going to pull in more. And so what that's going to do is it's going to make this bond more ionic, less covalent, because it's going to pull in more of the electron cloud this way. And so in this sense, it's going to be more polarized. This bond is going to be more polarized than this bond over here. Does that make sense? And so in that sense, this end becomes more delta negative, that end becomes more delta positive, but they don't add up because this has a positive net charge over here. But it's tricky because of how we're comparing things. We don't want to start comparing. Because the charge on nitrogen is between +1 and -3, you know, somewhere between there. So anyway, the net result is this is a more polarized bond because the nitrogen has a positive charge. Versus over here, this is a less polarized bond. The nitrogen doesn't have any positive charge associated with it. Formal charge we're talking about. All right, now let's try something here. We're going to try another species. We did ammonia, ammonium, and we're going to do this one. What's this called? Oh, good. Amide or amide? Amide or amide? Where have you seen it before?
Homework.
In the homework and also in that, in the acid-base chart. You might have seen this in the acid-base chart and recognize this as what? What stands out about amide? Yes, right. It's the strongest base in our in that chart there. It's the strongest base. In our chart, it's not the strongest base. It's close. And so, as far as acid-base properties go, it's a powerful base. How about metathesis? Do you expect it to precipitate much with anything? Not really. I mean, like ammonium, it's just the negative version of that. Might not precipitate with much. How about redox? Do you expect to be able to burn this stuff? Will amide burn? Like ammonia and ammonium? Ammonia and ammonium will burn. Will amide burn? Yes. Nitrogen is electron rich in this. Well, okay, that's fine. We get some, but we can get some additional information if we do the Lewis structure. So can you write the Lewis structure for this? I want the Lewis structure, and I want you to tell me the oxidation states, and I want you to tell me the formal charges on this. And so go ahead and do the Lewis structure.